Hello, and thank you for joining me for the fifth data analysis bootcamp class. Today we're going to discuss bivariate analysis, and we'll get really deep into correlation and interpreting that correlation. Before we get started, let's talk about and review the mnemonics from last class. Okay, so in our last class, the first thing we discussed was the bar plot, which is really great for highlighting summary statistics, most often comparing the summary statistic, an average or a median from each one of the features in our data set. And it really allows us to see which one's higher very easily, which one's lower very easily. Like our candles on the cake here, we can very quickly see which is the highest and which is the shortest. A cool thing about Seaborn is that we can also use matplotlib to extract the bars and highlight different things like the edges on the bars using the patches attribute. We also discussed the line plot, which is very simple, kind of a classical plot, and it really allows us to understand trends and movements over time. And because of its simplicity, it is really great for comparing different features, different classes over time in a category. Okay. We also discussed the histogram plot, which allows us to essentially control how much noise we're moving in. With the bins argument, we can either make them larger or skinnier and control how much noise we are removing from our distribution, the shape of our distribution. This is almost like simulating the fact that, or if we were to have a larger sample and remove that noise that we get from taking a smaller sample. We also discussed the KDE plot, which really allows us to plot the outline of a distribution. It is very simple in that sense, kind of like a smoothing or a rolling average of the outline of the distribution. It can be valuable to turn up, increase or decrease the amount of smoothing happening so that we get some detail where we're actually seeing the data in our distribution. And we also discussed the box plot, and like I've mentioned already many times already, it is very great for highlighting the outliers in our data set. It generalizes the whole distribution in favor of focusing on the outliers. And the cool thing about Seaborn is we can control the whiskers, how long or how short the whiskers are in our box plot, and really focus on which outliers we wanted to discuss or we wanted to talk about, wanted to focus on. And this is especially valuable when you're doing a presentation and would prefer to focus on a certain range of outliers. Okay. We also discussed the violin plot, which is the KDE plot on either side and mirror image so that we can, it's meant to allow for the human eye to notice symmetry better. It's supposed to be a little bit easier to see the mirror image to the KDE plot versus just the KDE plot by itself. I don't know if I specifically noticed that overly, but what I do notice is that our eyes are good at noticing symmetry and when things are not symmetrical. So cool thing about this, using the split equals true argument, we can plot two different categories next to each other and how the distributions are affected by those categories. This allows us to really notice those subtle details because again, our eyes are geared towards noticing things that are symmetrical or not symmetrical. We also discussed the boxen plot, which is a hybrid of the box plot and the histogram plot. This really allows us to visualize the distributions that lead into, understand the tails that lead into the outliers. It gives a better sense of where we should really be classifying outliers as they are. So this is really my preferred version over the box plot, the kind of modern day box plot, the boxen. We talked about the swarm plot, which allows us to see really so much detail. Unlike all the other plots that we've discussed up until now, they generalize in some way, which is generally very helpful when we're analyzing. Sometimes we want to see a lot of information, and so the swarm plot allows us to get that really fine level detail and really see things that would otherwise be unseen. Okay, we discussed the count plot, which allows us to understand the balances between our different classes, see if there is an imbalance in favor of one class or the other, and make comparisons of those frequencies. Lastly, we discussed the dis plot and the cat plot. Those are figure level plots in Seaborn that allow us to subsection our data by different categories on the rows and the columns. The disk plot allows us then to inspect how the subcategory or subcategory affects the distribution, or how the distributions are different by many categories, and really gives you a really fine detail understanding of the distribution. Cat plot is much the same, but we can now subsection our data by the categories, and then inspect how the final, that group of categories is, or another features categories are affected by that. Okay, so let's get started on our bivariate bootcamp class. Okay, and so starting the 5th class of our data analysis bootcamp, understanding bivariate relationships. This is very, very important. We want to understand the correlations and relationships. This is, we discussed so much in the last class, is how to understand the univariate relation, not really univariate analysis, understanding one feature at a time. We want to take that a step further now, and now that we can understand our features, we understand them in comparison or with each other. See if we can extract more insights. What is bivariate analysis? So bivariate is really the simplest form of quantitative analysis, in a sense meaning that we are comparing two continuous variables together. So we are normally concerned with us, understanding the association between x and y. So in general, we could say, is it positive or is it negative, right? We really want to understand this relationship. Okay, so we'll be concerned with things, patterns, directions. I want to also notice that there are outliers, because outliers, and we'll discuss this as we go through the class, and you've heard about a lot in the univariate analysis, but it doesn't stop here in the bivariate analysis. Outliers really have a big impact, and so we at least want to identify them so we can understand how it's distorting our bivariate analysis, or if it is distorting our bivariate analysis. Okay, so getting into some details about why we would want to understand correlations and relationships. So to get started, we want to use them to identify patterns and the relationships in our data set. We really want to understand how this feature or another feature is interacting with the other data set as a whole, or between these two features to really get started. This can help us have almost a predictive power, in the sense that if this always causes this, or when this happens, this always happens, we can start to better position our company, better position our assets to take advantage of that or prevent risk. So we start to gain by better understanding the relationships and patterns in our data set, patterns between the relationships, patterns between the features, sorry. We can gain almost a predictive power, not exactly machine learning at this point, but we're starting to get a sense of that relationship, and relationships often repeat. There's some correlation between those two. Okay, another really important thing that bivariate analysis can help us understand is variable selection. Okay, now what I mean by variable selection is, in this modern day and age, we often have just so many features in our data set, so many different columns to choose from. Most of them for our specific problem will not be as valuable as we would hope, truthfully. So what we need to do is, because we have so many, we only have so much time, we really need to focus on the most important features where we can best dedicate our time. And then in presenting our results, we really want to focus on the most important variables that are going to affect our business decisions that we're trying to support. Okay, so our mnemonics to help us remember these points. We have our first one here, our guy dancing at the club. And so can I ask you, when was the last time you went out dancing? Okay, now think of a time that you went out dancing. For me, the last time I went out dancing, and a common one that students have told me, was the wedding. Okay, I don't know if lots of data analysts only dance at weddings, but that was a common response that I had. So we could imagine that we're at maybe the last wedding that you went to, or the last time that you had been to a dance party. Okay, so we are at this dance party and we are looking around at all of the people dancing, having a good time. And we can really notice, now being data analysts, being professional data analysts, we can really start to notice the effect of, we can really start to notice how all of the data points are interacting together. from this, we can start to get some hint of how the people are moving around, not just the data points. They're more important than that, but really starting to understand maybe who is in a relationship, who is not in a relationship, and maybe more importantly, who would maybe want to dance with us. So we can start to use our predictive powers as we're using our powers of observation to understand who might dance with, who would we want to dance with. That's just, there's lots of available women or men around here, and we're saying, I wonder if they would, I think I'd want to dance with them. Okay, but I think they might dance with me. They're not in a relationship. They're open to have a new dance partner, let's say. Okay, so just to be careful. So if we can imagine we're at the wedding though, we want to make sure that my grandma really likes to eat sweets and stuff. So if we're at a wedding, we would want to be very careful to maybe get in there, make sure that we're analyzing this and being very careful to choose the best desserts. You can see my niece right here is spending a lot of time choosing and deciding which dessert to select at the wedding. And so what we would want to do, we might want to get the desserts before my niece eats everything. Okay, so we really want to put some time into and choose the best dessert, but we also want to put some time in our data analysis and choose the best variables, the most influential variables in our data analysis. Okay, some other things that we really want to understand when we're dealing with correlation and relationships. I think a major thing that we want to understand is the strength and the direction of the relationship. Okay, is it positive? Is it negative? I think that kind of seems probably as the line upward sloping or downward sloping. This helps us determine if it's a positive decision and or positive relationship and how they're related so that we can better make or take advantage of opportunities, prevent risks. The more that we can understand this relationship, simply positive or negative, we can better prepare our company or business uh, for for those events that happen. If the relationship is a negative one, well, maybe we need to prepare things, uh, more of a defensive position, or if it's a positive relationship, maybe more of an aggressive situation. So it's simple and straightforward, but really we want to prepare. We want to think about this type of relationship, either positive or negative, or even more complex, as we'll see. Okay, we use this to help us make decisions. So one of the important things that we want to do is we want to identify the key drivers in, let's say, our business problem that we're trying to work on, that we're trying to support. We want to identify the key drivers that are going to support that decision, that are going to help our income, really optimize the strategy, make things I kind of work better, I guess you would say, but make things move in the direction that we want to. We want to understand, if we can understand what is key in driving, this is the factor that we're concerned about. We can understand the things that most impact that are going to be the ones that we should focus on, the key drivers of our situation. Okay. We also want to think, as we go through this, we talked a lot about the bivariate relationship, but we're going to come to a point where we need to think of a more multivariate situation where, and that kind of really true, that life doesn't really happen just, you make one decision that, it just affects one thing. When you make decisions, usually it affects multiple impacts, or it has multiple impacts, even if you don't want it to. Okay, so we want to really understand how many of our variables work together to impact our target, the thing that we're concerned about. Or on the other side, we want to understand how this relationship will affect this one feature, this one X variable will affect many different targets, or the impact of it more in a multivariate relationship. Just thinking about, there's going to be more than one thing that could be caused by making this decision. So we want to understand all of those and how they work together, how they could be positive, how they could be negative, and really prepare for those as best we can. Okay, and use the data to help us prepare. Okay, so thinking of this, to help us remember, we got a fun little mnemonics here. I have a question. Have you recently made a big life decision? Okay, so most of my students, the ones that they have offered to me, just because I can't hear you, you might be in the same situation as lots of my students, is they had recently switched jobs, or they've been thinking about changing their job. And I mean, I think that really works, because really that's a big decision. Where you go every day is a big part of your life. And so the one thing we want to think about is we want to put a lot of thought into that decision because it really could change the whole direction of your life, right? If you choose one job versus the other, the direction, you can't really get away from the fact that it's going to change the direction of your life. And so you want to think about really every big decision that we have. We want to think of it as or consider the impact, the direction that's going to have on many features in our life. Before we would make this decision, we I think this is something that we do. We think through all of the things that we want to identify. That could be the positives, the negatives, all of the things that are going to go into impacting this decision. And really, even as you're preparing your job resume, you want to think about all the things that could support that decision, right? So we really want to identify what are the key drivers. You want to look at what the job posting is. You want to identify what skills I have and what skills are appropriate for this job, right? So you want to identify the key drivers when you're making this decision. And you want to do kind of as thorough of a job as possible because making a wrong decision here, it really changes, could set your life in the wrong direction. It's hard to change once you make that change. Okay. On a multivariate basis, we want to really think of the impact our decision is going to have, right? So getting a job is great. You're going to get hopefully more money, maybe less money. But there's more to consider than just that, right? I think this is how we just naturally think as well as we're just trying to give it more of a structure to the way we think. But we really do think of things in a multivariate basis. We understand intuitively that there are more impacts and more factors going into a decision than just X, more money. I want this job for more money. Really, you have to think the benefits and stuff like that kind of along the money line, but also who you're working with. What type of work are you going to do? Because even data analysis is kind of a broad category. Maybe you want to be a business analyst. Maybe your data analyst job is going to be more in SQL versus Python. And we really have to think through, do you like writing in SQL, right? Is that something you really want to spend your time doing? Or do you really want to get to the analysis? Do you want to be building pipelines, or do you want to actually be doing the analysis all day long? And so even your colleagues as well, because you think one relationship goes bad with one colleague, you're not getting along with one colleague, that's going to affect a lot more things than just that relationship. That colleague could talk to other people, could put you in a bad frame of reference with lots of your colleagues as well, your boss even. And so that could be quite damaging. We want to think about that all of our decisions really are usually the inputs are usually more than one factor in how we make that decision, but it also could be affecting many things. And it's a good life lesson as well. But we want to be considering all of those factors, all of those positive and negative results or potential results from making any decision in our lives as well. Okay, so now talking about variance. Variance is the measure of how things move around. So really what we're saying is the average of a feature and how things move to the left and to the right. And what we're going to do is, if you look at this formula down below, we're going to take the average, which is this bar on the top, and then x, which is every sample I for every row that we have. We're going to take how far away it moves from the mean, and we're going to square this. So variance is in the square of the unit. The reason we square it is so that the negatives and the positives don't cancel each other out, because the negative times the negative is a positive, and so we'll have all positive units. So really getting a sense of how far away it's moving from the mean. It is in units squared. And so it starts to become, although it's possible, you could say the number of bananas, let's say bananas squared. And you're okay, well, 10 bananas squared, okay, that's 100 bananas. It's not so hard to do. It's still very possible. You see, as we go a little bit further, it becomes a little harder to really get this into human understandable terms. Okay, so we use variance to help us understand how far away things are moving from the mean. And it gives us a good sense of the unit measurement, although we do have to do a little calculation really to understand in terms of the unit of measurement. It is very helpful to help understand how things are moving away from the mean. In this, so in this picture right here, we have our middle lamp post and all of our data points moving from the left and to the right away from our mean, the middle place of our data. Okay, this is in context of the middle and how things are moving away or spread out around the middle of our data set. Okay, so from variance, we get to covariance. Okay, and it works very similar in the calculation. And covariance, we'd love to really would be what we'd love to understand. It becomes a little bit confusing for a reason, and we'll discuss that. But it works really well in describing how things move together. So, or how they're generally above or below the mean together. Okay. So what this is saying is for every sample of x, we're going to minus it from the average of x. For every sample of y, we're going to minus it from the average of y. And there's no square here because we're times x times y. Okay. And so it kind of cancels each other out. Then the negatives would cancel each other out, and the positives would cancel each other out. This really gives us a sense of how things move together generally, how above or below the average they are together. Okay. So this is a really good sense of what we would want to do. The problem with this is its covariance is really affected by the scale of our units and really the unit of measurement. Okay, so it's one of those things that if you have, let's say, bananas times kilometers, you have a covariance of 100 banana oranges. It's kind of, it becomes a little bit confusing. You could maybe think through that. It's unfortunately not super relative, but also because the scale of the unit of measurements are very different, it becomes very hard to compare covariance between this data set and another data set. So you could say, oh, my features have a really high covariance. But how do I know what that number is? It really depends on the scale. So covariance is also, again, then very sensitive to, say, the scale of measurement. And it becomes a little bit less relatable, and it requires a little bit more explanation if you were to communicate these results. Okay, describing a little bit further why covariance is a little bit difficult for us to work with, or kind of impractical for us to communicate our findings in this regard. So if we have variance, you can imagine if we have measuring mice and one feature, mouse squared is not super confusing. You have 10 mice squared. That's okay. It's 100 mice. It's a lot of mice, but it's possible to get there. Problem is when we have covariance, we have unit x times unit y. So if we have mice in one, chameleon in another, we have mouse chameleon or a chimeleon. And if you didn't know, that was the name of a mouse chameleon, a chimeleon. And so one of those things, it's, obviously that's a little bit confusing. He's very cute, he's adorable, but a little bit confusing in terms of communication. Like, how are we going to communicate that properly if, well, it doesn't really exist? It's not a real unit of measurement. Chameleons are not easily understood, not really a unit of measurement. So we tend not to use covariance as the standard measure of our relationship, because it's also not comparable to other data sets. Even if you have a good sense of what 10 chameleons are, you have a hard time comparing that to banana oranges or something along those lines, right? We have a really hard time. We would have a very hard time, especially with the different scales, making comparisons between different values. So we really don't get a sense of how good, how strong this is, because we need to do this comparison throughout our whole data set. We can't be thinking about, okay, well, this was really strong, this was really weak, the chameleons were sort of strong, the banana oranges were very weak. It just becomes very very confusing and a lot more cumbersome than we would really want, especially when we're communicating our results. Okay, so the reason that we needed to discuss, or we need to understand the concept of covariance is because we use it to calculate correlation. Correlation is what we'll probably use at the end of the day to communicate our results and really to make comparisons between different features in our data set and really understand the strength of each of those relationships. So what we do is we take covariance, we look here at the bottom, take covariance, and we divide it by the standard deviation of x times the standard deviation of y. So we're taking our chameleon unit of measurement divided by the mice times chameleon. So chameleons again, and we get rid of that weird unit of measurement, and we're able to get a number between -1 and +1. So this gives a much more comparable unit of measurement, a much more easier to understand metric, especially when we're making comparisons in our data set, when we're communicating our results. Okay, so positive just represents to that it's a positive slope and negative is a negative slope. It doesn't really relate to the angle exactly. What it relates to is how close it is to one is going to be how tightly packed our x and y variables are on that line. The more spread out they are, the less correlation we have. But the more tightly packed, whatever the slope of the line is, the more closely packed they are to that line, the more or the higher closer to one we would have either positive one, or if it's downward sloping we would be negative one. Okay, this is again a much more easier way to communicate our results, especially when we're sharing our findings to people that are maybe not data scientists, or very likely lots of them will not be data scientists or even data analysts, or have really done a lot of studies in math. And so, but we still need to make sure that everyone understands what we're talking about. And correlation is a great metric for that. Okay, so although correlation is a powerful metric and a really good starting. It's not that it's wrong in any way. It's in lots of essences, although it took us a couple steps to get there, maybe a little bit more complicated than just finding the mean by itself or the average by itself. It is still a simple metric, and so we have to be aware that it might be not telling us the whole entire picture. Okay, and it might be kind of missing some things. It might be misleading in some senses. It can be affected by outliers, as we discussed, but also be affected by different kind of interworkings in the relationship that we need to be aware of. And we can usually find out by simple visual inspection. Okay. So we have, as we saw, we have a nice positive correlation right here, about 0.56, not super great, but a moderate correlation between these two variables right here. And we have a weaker negative correlation right here. But you almost notice that there's two kind of patches, two clusters of data right here. And as you look at every individual one, that correlation seems to disappear. So one of the things as we go through our workbook, we'll try to see if we can identify what is really causing this difference in clusters almost. And why then, a question that we would want to ask is, why is there not any correlation within these clusters? Are they maybe, this is dealing with different animal species, so maybe they're from different islands or different colonies. And so what we would want to do is think about, well, is it maybe just the size of the colonies for each one of these? The relationship isn't true amongst a colony individually, but maybe as the species as a whole. And then is it really, if it's not apparent in any given colony, would that really be as true of a correlation? In fact, we would want to kind of consider this. Again, the metric can kind of hold, it tells us a negative correlation, but there's more to the picture. And this is why we always want to supplement our correlation analysis with a visual inspection. There's lots that our eyes can see that simple little metrics cannot, and we need to understand what they could be missing. Maybe they're doing a great job, and maybe they're not. And we need to understand this before we want to communicate our results. We really want to visually inspect and really understand what else could be causing this positive or negative, this correlation, this high or low correlation. Okay. Okay. So the lastly, it's important to mention that outliers are very important. We talked a lot about this in our univariate classes. They affect correlation, not in the exact same way, but they do have a very large impact on our correlations as well. And they can be either positive or negative. It's not just going to skew the result. It could make the result look a lot better. We really want to pay a lot of attention to them so that we understand if they're hurting, if they're helping, and then really what we need to do with that, right? Because we really want to understand that relationship as true as possible. If the outlier is really making our relationship look better, that we don't know. So I kind of like this tower of the Leaning Pisa where the outlier guy is pulling the tower the other way, right? So he's making it look like the tower is straight, right? It's perfectly straight tower. As we all know, the Leaning Tower of Pisa is not straight, right? So he's kind of skewing that relationship. And the same thing here is that we don't want we want to really understand the trueness of a relationship, the reality of the way it is, not how we hope that it is, I guess you would say. And so to understand the true, accurate relationship, we want to understand our outliers and how they could potentially be affecting our bivariate relationship. Okay, and so to recap the mnemonics from this class, first we talked about when we were at the wedding, we talked about being a data analyst at a wedding and using our data analysis abilities to determine who, to really start to understand, survey the land and understand who's in a relationship, who's not. And maybe from that ability, as we start to understand our data points, the other people around us, we could really get a sense of, we could try to predict who's going to dance with us or not, who's single, who's available, who's not, and who do we want to stay away from. And really, going a little bit step further is maybe someone that would say yes when we chose to dance with them. So we can use our data analysis abilities to understand relationships, but taking it a step further and not necessarily predicting the future, but get a good sense of how to position ourselves to take advantage of opportunities when they do arise. Okay, we also wanted to think about, if you remember, my niece was at the wedding as well, and she really likes her sweets and stuff like that. So what we really want to do is we want to make sure that we are selecting the best sweets. When we take them before my niece has a chance to get there and choose the best sweets. She's putting a lot of time into choosing the best ones here, and we kind of want to do the same things. We want to put some time and thought into which of the variables, which of the features are going to be the best predictors in our data set, which are going to be the most important ones that are related to our problem, and the ones important to kind of narrow down our search. We want to select them down and really reduce the amount that we're going to go through and analyze. We also wanted to understand the strength and the direction of our relation, of the relationships. We talked about how finding a job, really choosing a good job position can really affect, our whole direction of our life. Choosing poorly could put our life in a bad direction, and so choosing properly is very important. And with that, we want to understand, the key drivers, things that are really going to impact that final decision. Money is obviously important, but work conditions, how close it is, what the actual job is, what are the jobs that it could lead into. All these things are very important in making our decision about which job to choose. We also discussed the understanding on a multivariate basis. As we make a decision, we want to understand not only how our decision is going to impact, the here and now, that we make more money, but we also want to understand how things will, the multivariate situation, how things are, the many things that are going to be affected by making this decision. You can think of, you're working at this new job and your colleagues, and maybe you have a disagreement with one of them. It's just not a disagreement between the two of you. That colleague is probably going to talk to other people, and it becomes kind of drama in the company, and more people are going to know about that. There's going to be, every choice in life, it has more than one effect, unfortunately. It kind of works that way. We don't just generally, it's not a cause and effect. There's many things that are going to be impact. Okay. So next we talked about variance. And now variance is really describing how on a univariate basis, how things move away from the middle. Okay, so we need to understand variance because that led into covariance, which are how two variables move together. And we discussed the problem of covariance is that we are sometimes not really sure of the unit. It's kind of confusing to interpret the unit of measurement. We use the example of if we have mice in one column, we have chameleons in another. We get the covariance between those two would be a chameleon, which is very cute and adorable, but very hard to interpret. And even if you could interpret, what 12 chameleons are, it would be hard to understand then how 12 chameleons relates to 15 apple bananas, right? It kind of loses that sense. So the unit of measurement becomes very important in covariance. To help us deal with that, we do a transformation of this. We divide the covariance by the standard deviation of x and the standard deviation of y, and we get a nice number between -1 and +1 that gives us a hot and cold relationship, and we call that correlation. Okay, and so the correlation is a nice summary statistic, very simple and easy to interpret between just amongst the relationships in our data set or in with other data sets. It's also very handy to communicate. Everyone can get a good sense of what a 0.8 correlation is if it goes up to 1, and lots of people understand this, and so it makes it a lot easier versus a chameleon, which not many people understand. Okay, and so we want to be careful though, because getting a simple summary statistic can often miss certain things, right? It can be leave a little bit to desired in the sense that we're going to be missing some things. And so we really want to supplement our correlation analysis with a simple visual inspection and really make sure that it is really doing a good job of summarizing the relationship, or is there something else going on that we need to inspect a little bit further? We discussed how outliers are always affecting our summary statistics, and correlation analysis is no different. It will affect a correlation for the better or worse, right? So it could inflate or deflate the relationship, and we want to understand how it's doing that so we can better prepare ourselves and better understand the data. We saw this guy pulling the leaning tower pieces the right way. We might be getting a better answer. But is that really the accurate answer that we want to understand? Does it accurately describe the answer by the effect of the outlier? Maybe not. So we want to be careful and at least understand these outliers in our data set. Okay, so we talked a lot of mnemonics today, lots of unique pictures, logical pictures, some funny stories to go around them. I use colors throughout the workbook to help kind of connect. It's not the most powerful mnemonic, but it helps us connect things in our memory and should help us draw us back to the content, to the pictures. Okay, I told some stories around things, and we told stories as we went through the class today, and it was just to connect the lessons learned, connecting the memories to the past, but also connecting them together. Okay, and some word associations through this. I tried to use when I was telling the stories, I tried to use location, 3D space, because our minds just work better remembering 3D spaces. Okay, I try to be funny as I was telling to bring a little bit of emotions to this. Your job is to now go back. You could see that there's a lot of extra writing in the class. Okay, so go through and review and read the slides. Make sure you're going through, and hopefully as well in this lesson that you'll see on DataSimple, there's a lot of extra material underneath the videos. Okay, so read those as well to help reinforce this concept. Do a little bit of recall. Hear the things in a different format, a different wording will help you really understand and really lock these concepts in your mind. Okay, so I will see you for the next video. Hello, and thank you for joining me for the 5th data analysis bootcamp class. We're going to go through the Python workbook, and well, let's get started. So here, downloading some different libraries to get us started here: pandas, seaborn, matplotlib, and numpy are standard kind of data science libraries. The data set will be included at the end of the class. If you want to download the actual data set and upload it from your Google Drive, this is the code that you would use. If not, the data set's available in my GitHub reservoir, and you'll be able to download it directly from there. Okay. Let's just get started working on this. Okay. So if you've been noticing, I don't like the standard colors in using them. I get kind of bored of those default colors. They're nice. You just kind of get bored of them. I like to make color palettes in here. So I'm making a color palette right here of some set colors, and we'll just play around just to make it a little bit different as we go through our class today. So getting started, I think this is always important, even in a bivariate relationship, it's really important to understand our variables a little bit. Okay, so here what we're going to do is for feature in df columns, do a figure size of 6,3, so 6 by 3, width by height. We're going to do data type equals to an object, SNS count plot if it's an object, and choosing a palette color right here, and then x ticks rotation 60. Else, I'm going to do a hist plot and do a numerical value, and this is only going to use one palette color, so I'm just going to do palette equals 0 and use the first color for my palette. Going to add a title regardless, and then show the plots. This doesn't all just happen on top of each other. Okay. So I think it's always really important to highlight so we can save time later on in our data analysis. Even when I'm doing one for myself, I always write down these little notes. I saw this, there's an imbalance here. Especially as you really start pre-processing your data, you start getting further into your data analysis. It's fine to come up back to the plot, but it does take a few extra seconds versus just looking at your notes. So it does really speed things up, just writing a short little note for you. And then if you ever have to show this to anybody, your notes are already done for what you're seeing, okay? So it's just a good idea. Again, it does seem a little bit, I don't want to do this just for myself, but it will end up saving you a lot of time. Okay. So getting into some different plots that we can do in our bivariate analysis. And we'll go a lot more into detail in this in future classes, but just giving a highlight right now of the heat map. So this shows really the correlation matrix that we talked a lot about, and really highlighting when it's negative and positive. It is kind of, unfortunate the way it works is that you can't really get a good sense of this one is stronger, but which is actually, the stronger negative, and where's the strongest? Is it right here? Is that the strongest positive, or right here? So I think a really good idea to do this is you note equals true, puts the numbers in there. It can be helpful. You see it's a little bit squishy though, right? So I actually like to make this a little bit bigger first, put a figure, plt.figure, fig size 8 by 6, and then I'm gonna put my correlation matrix into that, and we can start to see we get a little bit nicer plot here. Okay. Looking at correlation, making this look a little bit nicer. I don't like the standard color in Seaborn. Maybe you do. Not my cup of tea, I guess. The lava color is kind of, yeah, I don't know, it's not my thing. So I usually use crest equals, see if I feel like doing it really quick, I use the preset crest. I'm gonna add a title here and just notice here that I'm doing a line break before and a line break after. This is to add a little bit of space before and after the title so it's not so crunched up, just crushed right into the top there. I think it makes it look a little bit nicer. Font size 16, font weight bold, font weight is how you change the style, and so bold. And then plt.tight layout is just going to make sure everything is sitting nice, because I did I did some more formatting to this heat map. It's just a good idea, although I didn't do very much. It is still helpful just to kind of reorganize everything. It's not going to make everything tighter, it's just going to make sure the spacing is correct on everything. So we can do that. I often like to play with this diverging palette though. Okay, so the way diverging palette works, let me just run this first. It allows us to select two different, a high and a low value. So this is fine when we have positive and negative. Crest works well. We can already see the high and positive ones, but if we want to have custom colors, diverging palette is very handy. Okay, so we're going to do this, and this allows us, it's very hard to know because you just need to choose two numbers. It's from 0 to 360. If you don't know what those numbers look like, it's pretty hard to choose. So this choose diverging palette is a good little function that lets you go through and choose the different colors between these two. So what this is high and negative, or negative color, positive color. The separations, this is between how much kind of white space is between the two, distance between the two colors. Light is, or sorry, saturation, I apologize. S is for saturation. So if you go down to 24, gonna basically turn off the saturation. If you go all the way to 2599, it's gonna make quite colorful, I guess. So it really depends on what you want to add. And it's gonna once again to restart this. And then looking at L, that is how light our palette is going to be, and I'm gonna do what colors we want to get rid of. S, or sep, is going to be the separation. So it's the distance between the two outside colors, right? So really just adding more white space into the middle, how many colors we wanted this to be, and if we wanted it to be dark center or light center. I don't know if light center ever really works, but maybe it will for your situation. Okay, so playing around with that, I just settled on 22. I honestly find almost any of these two colors work together, but 22 and 20, I have to just choose two random ones and see what it looks like. And it looks quite nice. Right here we got a very customized, very unique correlation matrix that truthfully would be hard to do otherwise. And now we can really highlight what is the strength of a relationship, but also very much highlight which is stronger, which is weaker, and really understand which is the highest strength in our relationship. Here we're very isolating. The foot length between the ear conch in our possum data set seems to have the highest correlation. Okay, so we're learning a little bit of stuff about our data set. The skull width as well has a very strong relationship with handle width. And the site, though, and the case number, that probably relationship is a little bit skeptical because that's just where they were sampled from. And so they probably do have a correlation, but it's not something that we really need to understand in our data set. Okay, just going over the classic scatter plot. We don't really use this too much in sense. There's not really a lot that we can do with this in a sense. So what we often do is we use the reg plot. Okay, so what I'm going to do here is just to make sure none of the data was sitting on top of each other, because sometimes you would see it is sitting right on top of each other. We go jitter true y, jitter true x is going to move those a little bit, so it's kind of a little bit more spread out, and we get a better sense of how much data there actually is. What I'm also doing here is I'm doing scatter KWS color. So what this is going to say is this is really good practice with Panda or Python, doing some more advanced things with our plotting functions. It's really cool that we get to play around with this and just see, do some more advanced Python, but really see the results right away. Okay, so this is we're passing a dictionary to my function that's going to control a lower level function. So regplot is actually made up of a scatter plot and a line plot. Really good practice is passing a dictionary to the function to control a lower level function. It's going to pass this to line KWS or pass this one to scatter, the scatter plot, and change the color of the scatters, the dots, and then this is going to change the color of the line to make up the line plot. And then here, just looking at a different variation, we're noticing here in this one, seems to be like there's two clusters in this one. So we can go through this and explore this a little bit better. Here, I did a pair plot, and now what a pair plot is really good is really busy, if you could say that. It's almost too much to really get into detail with. The reason that we don't generally go into super detail with this one, we look at this as a starting point because there's lots of bivariate relationships. Which ones are important? Kind of hard to know when you get started. And so it's good to kind of go through this and use our eyes to start detecting patterns. You can see correlations here. Let's see a little bit of clustering going on in this data set in this column with ear conch. So maybe we can use that as well over here, ear conch. It's very interesting, a little bit over here as well. Seems to be a negative relationship, positive relationship, and kind of highlighting what would be more interesting, chest and what's this one? So chest and jump around there. Chest and belly have a seeming like a pretty positive correlation, which would make sense, right? So we want to expect that. It looks like a pretty solid correlation there, but this gives a better sense of our data than just it. I feel it's a good supplement to the correlation matrix, so we can visually inspect it quickly. This is not what you're going to present in your report, though. You're going to use this to figure out what you want to look at in a little bit more detail. Pair plot is great. I like the pair grid because there's just a lot of cool things that we can do with the pair grid. So same idea here. What we're going to do is we're going to do a pair grid and go assign it to G. I'm going to put in my columns right here. I'm just going to select column number, the third column, basically my numeric columns in this data set. Hue equals sex, and so I'm going to change the color by the hue. I'm going to map, on G, I'm going to go map underscore diag and put a KDE plot on the diagonal. I'm going to put a reg plot in the upper right. I'm going to put a his plot in the lower left. Okay. And here, notice this, what I'm doing is if I want to pass something to reg plot, because map upper is actually taking control of the reg plot, I'm referencing my function. Notice that there's no parentheses right here. I'm referencing reg plot because map upper is going to take control of that. And so I need to pass, if anything I want to pass to reg plot, I'm not going to put inside those parentheses. I'm going to give it to map upper, and it's going to pass that to reg plot for. Okay, a really cool thing that I like to do with this grid plot is we can, do a swarm in the middle. I think the most important thing is doing a residual plot with a reg plot. So we can do the correlation here. We can also do the residuals of the correlation, right? We can start to see and understand if our patterns in our residuals, we have to wonder if, what's really going on with that relationship. It can be a little bit deceiving and to understand what's really going on if we don't see these errors in our analysis and really get a truer sense of what's happening in our data sets. Okay, so it's kind of interesting. You see actually, so we have very low errors, and there doesn't seem to instantly be any patterns. We're seeing some clusters over here when we see by the population. We're seeing the population seems to cluster or make a little bit more errors on the lower side versus the higher side in the total length. So maybe population has something to do with the total length of an ad. Okay, it'd be interesting to explore a little bit more. Okay, line plot here, going through this. This is a really cool, LM plot is a really cool, powerful tool to do linear model plot and really look at those linear relationships. The cool thing about this is I can do X and Y, but now also we use the row argument to then segment this a little bit further. Okay, we're seeing here these two clusters seem to be pretty consistent between these two variables. A little bit stronger in the female category. Interesting. Okay. So what I'm going to do next here, I wanted to continue to explore this relationship. I need a couple more categories to be able to filter this by either rows or columns by the category and do an individual linear model and individual regression for each of these. So what I'm going to do that is I'm going to do pd.cut, cut this variable. I'm going to bin it, essentially go from the lowest just outside of the edge, go up to 4, and then from 4 to 10, just going on the outside to make sure I capture every data point. Send those to young and old just to keep it as simple as possible. Create 2 categories from the age bin. And what starts to get interesting is you're seeing by young, the clusters seem to be stronger between ear, conch, and tail. Still there in the older ones, but less strong, I would say. So let's make another category. And when I looked at this distribution, one of the first things that we did was plot the distributions. And so here what I'm kind of seeing is, it looks like there's almost a bimodal in this relationship. And kind of interesting. So maybe what I'll do is I'll do feet low and foot length low, foot length high. Again, just binning this into 2 categories. These are my outside edges, and these are going to be the names of my labels. 2. And as we see, really interesting here. So I now did the ear conch by tail, foot length bin. Actually turn down the height just so that we can see this in the video. You actually see it's a really amazing. We get the amount of that we're able to separate this now by those 2. It really seems distinctly quite a bit. Let's see if we can go a little bit more and do the same thing here. What we're going to do now is setting the column by the age bin. So we're going to do the foot bin as the hue and the age bin. So it's really interesting now. We're almost able to completely, on this side, completely separate this group over here to the side, almost on the right side here. So it's really interesting that the ear conch and tail are very highly rated to the age, or very much related to the age, but also the foot length. Very interesting. So something in this cluster, we could start defining it by the ear conch, the tail, the foot length being higher on the higher side. And so we're starting to understand what makes possums, well, tick, kind of understanding this. It's not really the population. It's not really, where they came from. Really related to maybe how possums age. I'm not a possum expert, but this would be the time that I would want to talk to a domain theory specialist who really understands those possums and can give me a little bit of insights into why am I seeing this, right? Because there's absolutely a reason. We just need to understand now why. Okay, that's the one thing the data can't tell you is the why. So thank you so much for joining me for this 5th data analysis bootcamp class, and I will see you in class number 6. See you there.